Black holes, some of the weirdest stuff in space, are still super interesting to astronomers and scientists. They're so strong gravity-wise that not even light can escape, which breaks all the rules of physics as we know them. Einstein thought them up way back in 1916, but they were just ideas until we had tech good enough to find them. In the 60s, some folks were looking at the Cygnus constellation when they spotted a bright star that was giving off a ton of X-rays. It was orbiting something invisible. Turns out, it was a huge black hole, now called Cygnus X1. That was real proof that black holes exist and got everyone hyped to study them. Cygnus X1 is about 6,000 light-years away and packed super tight. Its gravity is so intense that not even light can get away, that's why they're called black holes. Since then, we've found tons more black holes all over the place. Our own Milky Way probably has over 100 million of them. Even though they're hard to see, we know they're out there, from small ones made when stars die to huge ones in the middle of galaxies. Black holes mess with everything around them, even stuff far away. If anything gets too close, it's doomed. It gets pulled toward the event horizon, which is like the point of no return. After that, it gets stretched out like spaghetti and sucked into the center, called the singularity. This spaghettification thing happens because the gravity is way stronger on one side of the object than the other. Even though they're mysterious, black holes are awesome for testing the limits of physics. We're still trying to figure them out to get a better sense of space, time, and gravity. They're like silent watchers, daring us to learn more. The nearest black hole is about 1,500 light-years away, so we're safe for now, but people still wonder what they could do. In 2021, scientists got the first actual picture of a black hole in the middle of the M87 galaxy. It showed that they're not just empty voids. They have layers. The picture showed three main parts: the event horizon, where you can't escape, the photon sphere, where light gets trapped in orbit, and the singularity, the center where physics breaks down. It turns out that each black hole has different traits, so it's hard to put them all in one box. We can't send probes into them because they'd get destroyed, so we have to study them from a distance. There are a bunch of ideas about where they come from, like when stars collapse or from the early universe. NASA saw signs of a super big black hole affecting a huge area in M87. Even though it's tough, we keep pushing to learn more because that's what humans do. Back in 1963, Reuter came up with rotating black holes which blew people's minds. He thought there was a region around them called the ergosphere, where stuff wouldn't fall in right away due to opposing forces. He even suggested that this sort of system could cause an Einstein-Rosen bridge, or wormhole, could theoretically be created and connect different parts of space or other universes. The wormhole idea is wild. They could be shortcuts through space-time, letting us travel huge distances fast. But whether they exist and are safe to use is a big debate. They might be too fragile, and even if they're real, we still can't go faster than light. Still, they're fun to think about, like secret paths to elsewhere, sparking our creativity about what is out there. Scientists are trying to merge gravity with quantum mechanics into a theory of everything, and string theory is a frontrunner. It says tiny particles aren't points, but vibrating strings. The universe is like a giant guitar, with each string making different notes, particles. String theory might explain black holes, wormholes, and other weird stuff in space. These strings vibrate in extra dimensions that we can't see, but some argue that these dimensions affect the way the world works. String theory is tricky but shows deep connections between math and the world around us. Experimental proof is still needed as the higher dimensions are too hard to find. Still, the idea keeps scientists searching. As Edward Witten famously called, string theory is 21st century physics that accidentally arrived in the 20th century. Recently, some teams have made progress, suggesting that string theory could work, at least in simple models. The quest continues, pushing us to think bigger. Black holes change how we see the world and make us think about our place in it. They affect everything from neutron stars to gamma-ray bursts, shaping how the universe looks and acts. They were once just a cool idea but now play a huge role in how galaxies form, how stars are born, and how the universe changes. We are using better tools, like telescopes and gravitational wave detectors, to learn more. Seeing gravitational waves made when black holes collide confirmed old theories and opened new doors and new questions. We're also still trying to combine Einstein's ideas with quantum mechanics, and black holes put these rules to the test. Since the two sets of rules conflict each other in certain conditions, it makes scientists rethink everything. Black holes, wormholes, and how space-time work might hold the key to a better understanding of reality, including quantum field theory and gravity. Until then, they will keep us guessing and inspire new ideas. From Einstein to Hawking, to the string theorists, we keep trying to figure out our place in this universe. With every discovery, we are closer to solving existence itself, not just learning about black holes. Black holes don't just suck in stuff nearby. Their gravity affects how galaxies grow and what happens to everything around them. If something gets too close, the black hole will eat it. As stuff falls in, it gets stretched out like spaghetti. Scientists call it spaghettification. The gravity is so strong that it pulls the object apart before it disappears forever into the center of the black hole. Even though they're strange, black holes give us a way to study how the universe works in extreme conditions. We're still trying to figure them out, hoping it will help us understand space, time, and gravity better. They're like silent watchers, inviting us to learn more about the unknown. Even though the nearest black hole is pretty far away, around 1,500 light-years, people still wonder if they could hurt us. In 2021, we got our first actual photo of a black hole in the galaxy M87. It gave us a better idea of what they look like. The photo showed that black holes aren't just empty voids. They have layers. The first layer is the event horizon. Cross that line, and there's no turning back. The second layer is the photon sphere, where light gets trapped, circling the black hole forever. And at the center is the singularity, where all the rules of physics break down. It's a weird place that scientists can only guess about. All black holes have these three layers, but each one is a bit different. That makes them hard to study. We can't just fly into one to take a look, so we have to find clever ways to study them from far away. People have lots of ideas about where black holes come from collapsing stars to crazy stuff happening when the universe was young. NASA is looking at the middle of galaxy M87, trying to see how the black hole there affects things. It's tough work, but we keep trying because we want to know how the universe works. Back in 1963, a guy named Roy Kerr came up with this idea that black holes spin. He figured that around the black hole is an ergosphere, where gravity's so weird that stuff can't fall in. But the strangest part of Kerr's idea was that maybe, just maybe, spinning black holes have wormholes inside. These wormholes could be shortcuts through space, maybe even to other universes. It sounds like science fiction, but it comes from Einstein's theories. Einstein said that space and time are connected, making a space-time fabric. Big stuff warps this fabric, causing gravity. Wormholes would be like tunnels through this fabric, connecting far-off places, but they may not even be real. Even if wormholes exist, they might be too unstable to travel through. Plus, Einstein said we can't go faster than light anyway. But wormholes are still cool to think about. They make us imagine going to other worlds quickly, and maybe even other dimensions. Scientists are trying to find a theory of everything that combines gravity with the rules of tiny particles, quantum mechanics. One idea is string theory, which says that particles aren't points. Instead, they're tiny vibrating strings, like on a guitar. The way they vibrate makes all the stuff and forces we know. String theory might explain black holes, wormholes, and other weird stuff from Einstein's theories. These strings live in more dimensions than we can see, which is hard to imagine. It's like fish in a pond don't know about the world above the water. These sneaky dimensions could affect how things work. The math in string theory is bringing together different parts of science, showing how numbers and nature are linked. The search for a theory of everything is driving scientists to learn more. But even though it's cool, string theory is hard to test, because we can't see those extra dimensions. However, it still is getting people excited about space. One of the big puzzles is quantum black holes. No one has worked it out. A fancy physicist named Edward Witten said that string theory is 21st century physics that arrived in the 20th century. Recently, people are working on string theory that can solve black holes' problem but still simple. Black holes remain a challenge, calling us to explore the edges of the cosmos, where mystery could be found. Studying black holes is important because it makes us rethink what we know about the universe. Black holes interact with things around them, like neutron stars and gamma-ray bursts, showing us how the cosmos works. Galaxies, stars, and the whole universe probably are connected and affected by black holes. As scientific instruments become better to enable scientists to do better research. New stuff like gravitational waves, ripples in space-time from black hole crashes, have proven Einstein's theories and opened up new ways to study space. Scientists are still attempting to combine Einstein's theory of gravity with quantum mechanics, and black holes are a good place to test these ideas. Also, there are some conflicts that appear and we must solve it to understand all. They present many unknowns. They are a challenge, and also mean new discovery. From Einstein and his theories to scientists still working on the topic, the story of black holes is a journey through the history of science. With every new calculation, simulation, and photo, we get closer to learning the secrets of these things, and also the secrets of the universe.